Hey, this is Gary here. This week we were asked to make water-propelled rockets. We were given tape, cardboard, scissors, and sent away with our own devices to try and come up with the best design to go the highest, basically. After trial and error, a fair few times, percentages of water, how much pressure, weight, uh, where you put the fins in comparison to its center of mass, how heavy it was, we eventually came to a point where it wouldn't go no higher because we figured we came to the best recipe for this. After a few trial runs and a few designs, we came to the conclusion that the best design would be have it relatively long, the fins far away from the center of mass as possible, and obviously having a tip at the end so it can penetrate the air relatively well. So it was Newton's laws of motion that were utilised in this exercise. Objects at rest will remain at rest, and objects in motion will remain in motion in a straight line unless acted upon by an external unbalanced force. That's the first one. Second one being force equals mass times acceleration. And third one being force pairs, every action has an equal and opposite reaction. We were then asked to work out the maximum height that the rocket had reached. We did this by laying flat on the ground, using our arm to point out the height that the rocket had gone to, then put a protractor next to the arm to work out the angle, which we had was 70. Then stepped out how far we were lying away from the launch site, which roughly worked out to be 14 meters. So with that, we did 14 times tan 70, which equaled 38.46 meters high.